Hi everyone, welcome to Mathematics Mania YouTube channel. So in this video we will see the differential calculus in which we will try to see finding nth derivative of a function. Let y represent some functions of x which can be represented by y is equal to f of x for some function. So a function can be an algebraic function which comprises of square, cubes and quadratic anything, or it can be a trigonometric function, or it can be a logarithmic function or anything. So any given function we can try to find the derivative of a function. So calculus is one of the most beautiful intellectual achievement that we human beings have found. So this study, the study of change in motion, growth or decay, etc. is actually a calculus. One of the most important idea of differential calculus is the derivative of a function which is going to measure the rate of change of a given function. So this concept of derivative is very useful in the field of engineering, science, economics, medicine and computer science. So let's go and see how we can check and do the derivation. The first order derivative of a function y can be denoted by dy by dx, that is y1 is equal, we can represent it by either dy by dx or y1 or d1 of y. In the same way, the second order derivative can be represented by d square y by dx square, which can also be represented as y2, or this can also be represented by d2y. We will use all these notations interchangeably, however we feel the ease of the ease in the writing. So the first order derivative is achieved by differentiating a function y with respect to x for the first time. So then the first time derivative we will get y1, and differentiating again the y1 with respect to x, we are going to get the d square y by dx square represented by y2 or d2 of y, and so on. And if we are differentiating it again, we will get d cube y by dx cube. This can also be represented as y3, and this can also be represented as d3 of y, and so on. So this successively, if we are going to differentiate this function again and again, and so on. So first time we differentiate, we get the first order derivative, second time we get the second order derivative, and so on. If we are differentiating with respect to x n times successively, then we will get the nth order derivative of a function, which we will be representing by d power n of y of dx power n. This can also be written as yn, and this can also be written as dn of y. And for the simplicity of writing, in my next numericals and solving the problems, I will be using either y1, y2, y3 or d1, d2, d3. So let's see how we can find the nth derivative of a function one by one. So now let's start with power function, which is one of the easiest thing that we can do. Finding the nth derivative is nothing but successively differentiating the previous derivative n times. So that's how we are going to get the derivative of a function. So now for example, we'll start with a very basic thing. So let's take y is equal to x. So now let's try to solve a problem so that we will try to get some idea like how do we get the nth derivative of a function. So for simplicity, let's start with a very simple function, that is y is equal to x power 1. So we know that any function, any algebraic function, x power n, x raised to power n, y1 we can get y1 is equal to m into x power m minus 1, right? And y2 we can get again differentiating the y1 again with respect to x. So m is already there. So this we will so the y2 will be equal to m into m minus 1 into x power m minus 2. And y3 if we are getting, so what happens, m into m minus 1 into this m minus 2 will come here, so that is m minus 2 into x power m minus 3, and so on. Successively, if we are differentiating this, like now we have differentiated 3 times, and if we are continuing like this n times, so what will happen, yn is equal to, so let's observe a pattern here. So when it was the first derivative y1 m into x power m minus 1, this y1 was there and we are negating minus 1 here, and when we are taking y2 m into m minus 1, so minus 1 is there, these two terms, these multiplied terms are there from m into m minus 1 x power m minus 2, and when it is y3 taking the third order derivative, it is m into m minus 1 into m minus 2. When it is 3, we are writing it till m minus 2 and x power m minus 3, and when it is yn, so what will happen, m into m minus 1 into m minus 2 into m minus 3 and so on, m minus 4, m minus 5 and so on. What will happen, when it is 3 it is m minus 2, so, and when it is 2 it is m minus 1, so when it is n, this should be m minus n plus 1, right? So we have to take till m minus n plus 1, and this will become x power, this, observe this power factors here, so x raised to m minus 1, x raised to m minus 2, x raised to m minus 3, so this will become x power m minus n. So yn will be equal to y into m into m minus 1 into m minus 2 and so on. We will be getting till m minus n plus 1 raised to x raised to m minus 1. Also we know what is the factorial of a number, right? So n factorial is nothing but n into n minus 1 into n minus 2 into n minus 3 and so on. It will be till 3 into 2 into 1, right? So this is a successive multiplication from a number n till we get 3 into 2 into 1. So if you observe the same thing here, what happens here, m into m minus 1 into m minus 2 m minus 3, so we have the term till m minus n plus 1. So what will be the term after this one? So m minus n plus 1, so the next term will be 1 will be less than next one, so this can also be written as yn can be written as m into m minus 1 into m minus 2 m minus 3 and so on. We have m minus n plus 1 here, right? So if we are writing this, so if we have to write this m into m minus 1 m minus 3 as m factorial, we are missing the last terms from m minus n, m minus n minus 1, m minus n minus 2. So what happens? So the next terms that we have to get here is m minus, so in order to get the n factorial, we have to get m minus n factorial here, right? Because we have the terms till only m minus n plus 1, we do not have the terms of m minus n factorial here, right? So if we are multiplying this m minus n factorial in the numerator, we have to divide this also by m minus n factorial. So let's multiply and divide both numerator and denominator by m minus n factorial, this into x power m minus n. So now what we can write? So this circus we are doing just to make this m into m minus 1, m minus 2, m minus 3. So we have the terms only till here, m minus n plus 1, right? But we need we need, so this will be actually m minus this if we open the bracket, this will become m minus n minus 1, right? So the next, so if we write as m factorial, so this will become m minus n minus 1, again negate by 1, m minus n factorial, right? So in order to, if we are multiplying this by m minus n factorial, we have to divide also. So m minus n factorial will come in the denominator. So now this term m into m minus 1, m minus 2, m minus 3 and so on can be written as m factorial divided by m minus n factorial into x power m minus n. So this will be the nth derivative of the function y is equal to x power m. Yeah, so this was a very simple function that we took. So now let us see how to do some standard function. A similar function let me take. Okay, so let me go with a function with okay, so now we will see the next problem, that is y is equal to ax plus b raised to m. So again this is an exponential function. So now let's try to solve using the same identity, same formula, that is derivative of x power n is equal to nx raised to n minus 1. So the first order derivative of y is equal to ax plus b raised to m will become m into ax plus b raised to m minus 1. here we have to apply the chain rule here. First we have applied the derivative rule for an exponential function, and the coefficient of x should be multiplied here, so that would become, so the coefficient of x is a here, so we have to multiply it by a as well. So that will become a into m into ax plus b raised to m minus 1. So that will be y1. So now taking y2, so y2, so a is a constant and m is also constant, so that will become a into m into, so this will become m minus 1 into ax plus b raised to m minus 2. So this will be second order derivative. So if we see here what will happen, so we have to take the derivative of this ax also, so that would become into a, so that will become a into a will become a square into m minus 1 into ax plus b raised to m minus 2. And again differentiating with respect to x, again we will get y3. So now a square is constant and m into m minus 1 is again constant. Now differentiate ax plus b raised to m minus 2. This will become m minus 2 into ax plus b raised to m minus 3 into, we have to take the derivative of ax also, so that is a. So that will become a square into a, that will become a cube into m minus 1 into m minus 2 into ax plus b raised to m minus 3. Let me write it in a neat form. So that is y1 is equal to a raised to 1 into m into ax plus b raised to m minus 1. So y2 is nothing but a square into m minus 1 into ax plus b raised to m minus 2, and y3 is nothing but a square into a, that is a cube, that into m minus 1 into m minus 2 into ax plus b raised to m minus 3. So and so on, differentiating with respect to n times. So what will happen, that will become a. See, if you observe the pattern here, when we are taking y1, a raised to 1 m into ax plus b raised to m minus 1, the same thing happened when we did for x power m, right? So the same thing will holds good here also. So y3, so y2 a square, y3 a cube, yn, this will become a power n into m minus 1 into m minus 2 into m minus 3, and so on. We will get m minus, see, when we are taking the third order derivative, we are negating 2. So here we will be negating m minus n plus 1, right? That is n minus 1. So m minus n minus 1, that is m minus n plus 1, we have to take it. So that would become into ax plus b raised to m minus n. So here minus 1 minus 2 minus 3, so yn will become m minus n. So if we have if we have to put these terms m into m minus 1 into m minus 2 m minus 3 in a very simplified way, m factorial, we have to multiply and divide both numerator and denominator by m minus n factorial, so that the numerator will become m factorial, because m minus n factorial is missing in the numerator, so we cannot directly multiply in the numerator. So let's multiply and divide it. So that will become a power n into m minus 1 into m minus 2 into m minus 3, and so on, m minus n plus 1 into m minus n factorial divided by m minus n factorial into ax plus b raised to m minus n. So that will become a power n into m factorial divided by m minus n factorial into ax plus b raised to m minus n, which is the required nth derivative of this function y is equal to ax plus b raised to m. This is the standard nth derivative thing. So when this function itself is asked for finding the derivative of the function, we have to derive it and show. Suppose if they ask like 3x plus 2 raised to m, so we can write this formula yn is equal to something, and we will try to solve few questions which we will see how we have to apply. So now we have three cases here, right? So that is this m minus n, and see this n is the nth derivative and m is the power here. So we can have few possibilities here. That is case 1, that is when m is a positive number, when m is positive or greater than 0, right? When m is positive, it is very simple, the same holds good, that is m factorial divided by m minus n factorial into a power n ax plus b raised to m minus 1 into a power n, m minus n into a power n. And the second thing is case 2, that is when m is equal to n. So when m is equal to n, what will happen here? M minus n, so m minus n, when it is equal, this will become 0 factorial, and this will become m minus n raised to n, that is 0. Ax plus b raised to 0 divided by 0 factorial is nothing, 0 factorial is nothing but 1, and ax plus b raised to 0 is also 1. So yn in this case would become m factorial into ax plus b raised to m. So this will also become 0. So m factorial into a power n will be the derivative here. So now we will see when m is less than or equal to 0. So we saw the first two cases, that is m is positive integer, and the second case m equal to n, so where yn was m factorial into a power n. Now we will see when m is less than 0. For simplicity purpose, let's take m equal to minus 1 here. So when m is equal to minus 1, what happens? So we have y is equal to ax plus b raised to m, right? So now when y is equal to minus 1, so y is nothing but ax plus b raised to minus 1, which can also be written as 1 divided by ax plus b. So we can write this in the form of 1 divided by ax plus b, where our original function when m was positive integer, it was y is equal to ax plus b raised to 1, 2, 3, 4 like that. But now when m becomes negative, so the function will come to the denominator, so that is y is equal to ax plus b. Now let's start solving for this. So what happens here? Y1 is equal to ax plus b raised to minus 1. So same rule applying the exponential formula, minus nx raised to n minus 1. So what it will become? Minus 1 into ax plus b raised to minus 1 into minus 1, that will become minus 2 into the derivative of ax. The derivative of ax is nothing but a. So now that will be equal to minus 1 into a divided by this ax plus b raised to minus 2 can be written as ax plus b the whole square. So that is y1 will be equal to minus 1 into ax plus b raised to ax plus b the whole square. So now differentiating this y1 again with respect to x, what will happen? Y2 will be equal to, we have minus 1, we'll write as it is, let's write as it is, and 1 divided by ax plus b the whole square. This will become, here ax plus b the whole square is nothing but minus 2. So minus 2 into ax plus b raised to minus 2 minus 1. So that will become minus 3 into derivative of ax. So that is a. So that is nothing but minus 1 into minus 2 into a will become a square divided by ax plus b raised to 3. So minus 1 into minus 2 into a into a is a square, that is ax plus b raised to 3. And so and in the same way, similar way, if we differentiate once again with respect to x, what will happen? So here minus 3, so minus 1 into minus 2 into, when we take this to the numerator, this will become minus 3 into ax plus b raised to minus 4 into the derivative of ax, that is a into whatever is there, a square. So that will be nothing but minus 1 into minus 2 into minus 3 into a square is nothing but a cube divided by ax plus b raised to 4. Yeah, so if we observe the pattern here, so y1, let me rewrite it something like this in a very straight way. Y1 is nothing but minus 1 into a power 1 divided by ax plus b the whole square. Y2 is nothing but minus 1 into minus 2 into a square divided by ax plus b raised to 3. Y3 will be equal to minus 1 into minus 2 into, yeah, so y3 will be equal to minus 1 into minus 2 into minus 3 into a cube divided by ax plus b raised to 4. Observe the pattern here. So when we were taking the first derivative y1, so minus 1, y2 minus 1 into minus 2 a raised to 2 and here a raised to 1, y3 minus 1 minus 2 minus 3 a power 3 divided by ax plus b raised to 4. Therefore yn will be equal to minus 1 into minus 2 into minus 3 and so on until minus n. So this will become a power n divided by ax plus b raised to, here when 3 was there it is 3 plus 1 4, when 2 was there it is 2 plus 1 3. So here it should be n plus 1. So have a look here now. So if we see here minus 1 into minus 2 into minus 3 and so on minus n. So have a look here. When n is odd number and when n is even number, what will be the sign of the derivative? Just have a look here. When y1 minus 1 into a divided by x plus b the whole square, that is minus. y2 minus 1 into minus 2, that minus into minus will become plus. So when n is even, so this term will become completely positive. y3 minus 1 into minus 2 into minus 3, that is these two terms will be positive, again into minus, that is minus. So if we take the y4, 4 minus will make the positive sign again. So what we can write, this term will be minus 1 raised to n, that is when n is even, so this term will become positive, when n is odd this term will become negative. Okay, so and 1 into 2 into 3 into 4 into 5 up to n will become n factorial into a power n, write it as it is, divided by ax plus b raised to n plus 1. So therefore y is, yeah, so that is y is equal to 1 over ax plus b. So nth derivative will become yn will be equal to minus 1 raised to n into n factorial into a power n divided by ax plus b raised to n plus 1. So that will be our nth derivative of y is equal to 1 by ax plus b. Yeah, so the continuation of this, we will see what happens when we yeah, so next we will see the next question, that is y is equal to log of ax plus b. So here log of ax plus b, when we will try to differentiate first time, that is y1, the derivative of log x is 1 over x, so y1 will become 1 over ax plus b. And chain rule, the derivative of ax is a, so that will become a divided by ax plus b. So y1 will be equal to ax plus b. Just compare it with our previous result, that is y is equal to ax plus b. So yn will be this one, right? So now our y1, right, our y1, if you see here, a divided by ax plus b, a is a constant again anyway. So if you see, y1 is nothing but our y already, right? y1 is nothing but y already. So directly we can see, already since we have differentiated once y1, if we have to get the nth derivative in terms of this y is equal to ax plus b, so what we can do, differentiating with respect to differentiating y1 with respect to x n minus 1 times, because already we have differentiated with respect to y1, right? y1s. So we have y1 is 1 over ax plus b. Just compare it like this here, so differentiating with respect to n minus 1 times. Okay, so we will get yn here because already y1 is there, n minus 1, right? y1 will be equal to, a is a constant, take it some outside here, so d of n minus 1 times 1 over ax plus b, right? So that is this one. So what will happen? So you can directly substitute the formula here. So this is a into minus 1 power n minus 1, right? So here it is minus 1 power n, so it is minus n power n minus 1, right? And n factorial will become n minus 1 factorial, and a will become a power n minus 1 divided by ax plus b raised to n plus 1 minus 1, right? So now let's simplify it again. A into a power n minus 1, so here 1 would be there. A raised to 1 into a power n minus 1 will make it as a power n. Okay, that is a power n into, this will become minus 1 power n minus 1 into n minus 1 factorial divided by ax plus b raised to plus 1 minus 1 will get cancelled, and this is n. So yn for a logarithmic function will be this one. Okay, so since this is a continuation of this, I directly did this. Again we can do the same thing even for the log function also. We can take y1, y2, y3 and compare and do also. Both should be same. Yeah, now I will move to the next question. So that is the next question. Let's move on to something like this. Yeah, so now we will see some of the numericals. So finding the nth derivative of 1 over 1 minus 5x plus 6x square. So it's an improper fraction, so it will be difficult for us to find the nth derivative directly. So first let's write this fraction into partial fraction, and then we will see how we can find the nth derivative of this. Yeah, so let's try to factorize it first, and then we will convert this fraction into partial fraction. Yeah, so now 6x square minus 5x plus 1. So I have just rearranged these terms. So let me just split the middle term and factorize it. So this will become 6x square minus 3x minus 2x plus 1. So let me take 3x outside here, so it will become 2x minus 1. Again from here let me take minus 1 outside, so this will become 2x minus 1 again. So again this will be factorized to 2x minus 1 into 3x minus 1. Therefore our function y is equal to 1 over 1 minus 5x plus 6 square can be written as 1 over 2x minus 1 into 3x minus 1. So again this we will not be able to find the nth derivative. Let's try to put this into a partial fraction. So that would become 1 over 2x minus 1 into 3x minus 1 can be written as a divided by 2x minus 1 plus b divided by 3x minus 1 by partial fraction method. So here we will try to solve the value of a and b, and then we can substitute that values. So and now so that this will become 1 over ax plus b form, so that we can apply the nth derivative here. Yeah, so this can be written as 1 is equal to a into 3x minus 1 plus b into 2x minus 1. So now let's put x equal to 1 over 3. So what happens if I put x equal to 1 over 3 here? This term will become 0. 3 into 1 by 3 is 1, so a term will become 0. So which implies b into, so here this will become 2 by 3 minus 1 equal to 1. So this implies 2 minus 3 is minus 1 by 3. So minus 1 by 3 b is equal to 1, implying b equal to minus 3. So same way, put x equal to here of, let's put equal to 1 by 2, which implies here a into here. So this will become 3 by 2 minus 1, and this time will become 0 now. 2 into 1 by 2 is 1, 1 minus 1 equal to 0. This will imply 3 minus 2 by 2, that is 1 by 2 a is equal to 1, which implies a is equal to 2. So let's put the values here. So now this will become 1 over 2x minus 1 into 3x minus 1 will become a divided by 2x minus 1, that is 2 divided by 2x minus 1, plus b divided by 3x minus 1. b is minus 3, so this will become minus 3 divided by 3x minus 1. Now this is of the form 1 over ax plus b. So this can be easily, we can find the nth derivative of this function. So now yn will become this 2, let me take outside. So yn of 1 over 2x minus 1 minus 3 into yn of 1 over 3x minus 1 here. So now let me just directly apply the formula here. So if I am applying the so we have yn of 1 over ax plus b, that is nth derivative of ax plus b, that we already derived, that will be equal to minus 1 raised to n factorial a raised to n divided by a plus b raised to n plus 1. So now we will apply the same formula here, because 2 is a constant here and we have to take the nth derivative of 1 over 2x minus 1, and here 1 over 3x minus 1. Let's apply the same thing here. So this will become 2 into 1 over ax plus b raised to n will become minus 1 raised to n factorial and a raised to n. Here a is nothing but 2. So what happens here? Minus 1 raised to n into n factorial will be same thing, and instead of a raised to n we can write it as 2 raised to n divided by 2x minus 1 raised to n plus 1, and minus here. So put 3 yn of 1 over 3x minus 1, that is same thing again here. So minus 1 raised to n into n factorial, and in place of a we have 3, so this will become 3 raised to n divided by that is 3x minus 1 raised to n plus 1. So here if you observe 2 into 2 raised to n, a raised to m into a raised to n is nothing but a raised to m plus n. So 2 raised to 1 and 2 raised to n will make it as 2 raised to n plus 1 into minus 1 raised to n into n factorial divided by 2x minus 1 raised to n plus 1 minus 3 raised to 1 and 3 raised to n. 3 raised to 1 into 3 raised to n will make it as 3 raised to n plus 1 into minus 1 raised to n into n factorial divided by 3x minus 1 raised to n plus 1, right? And so what will be the yn? Our yn will become, here minus 1 raised to n and n factorial is common, so let's take it as minus 1 raised to n into n factorial, that's a common, let's take it outside. So this will become 2 raised to n plus 1 divided by 2x minus 1 raised to n plus 1, right, minus 3 raised to n plus 1 divided by 3x minus 1 raised to n plus 1, which is our required nth derivative of the term. Yeah, thank you for watching. Please let me know if you have any questions or queries. I will try to answer that. Thank you.